This is a lecture on weather, specifically from the context of natural resource management. Usually professors start these kinds of lectures talking about the significance of the topic. But weather has such an impact on all of us personally, I think it almost doesn't require much elaboration on my part. We all know that weather's important. We experience it every day when we step outside our homes. For the purposes of natural resource management, it's also almost self-evident that weather is probably the primary, if not one of the primary influences on ecosystems and so on. Weather drives productivity and cycles in ecosystems, but it also influences how we work with ecosystems. Can we light a prescribed fire today in a safe and controllable manner? Is it too wet to harvest this month? Those are all obviously things related to the weather. So let's start with a definition of weather. Weather is just the state of the atmosphere and associated variables that we measure, like air temperature, humidity, precipitation, wind, speed and direction, at some point in time. That's the important part. Weather is a right now situation. What is the state of the atmosphere right now for this sort of short-term period? When we're talking about long-term averages, that's climate. And I think most people understand that distinction. The bulk of this lecture is going to be talking about some of the important causes of weather and weather variation and the weather phenomena that we see and experience that's important for natural resource management. The number one most important driver of weather is the radiation from the sun. The sun's radiation and its variation across the surface of the earth and with time is the root cause of all weather. And that also explains why global climate change is inherently a weather problem, and that's because global climate change is caused by variation and a disruption of the energy balance of the earth. And that change is what is disrupting climate and disrupting weather on the earth. There are a number of things that influence radiation on the Earth's surface, and one of those things is clouds. So for short term, the clouds on a particular day can really influence the amount that radiation affects, for instance, temperature and other factors on the Earth's surface. Diurnally, so during a given day, the rotation of the Earth is important. Again, some of this is just so obvious as to almost not need stating. You know, we have night and day as the Earth rotates on its axis, and clearly that influences weather. the temperature that we experience is different at noon and at midnight. And that's due to the rotation of the Earth and the change in radiation conditions that we experience during that time. Over the longer term, the orbit of the sun, the orbit of the Earth around the sun influences radiation. We have seasons for two main reasons. One, the Earth is tilted on its axis, so it's rotating in a plane that's tilted relative to the sun. And two, the Earth orbits the sun. So during the northern hemisphere summer, that summer and warm temperatures are happening because the northern part of the Earth is tilted towards the sun, and the sun's rays are striking the Earth at a more direct angle. So they're basically more concentrated. During the northern hemisphere winter, over here, the Earth is tilted, the northern hemisphere of the Earth is tilted away from the sun, and the rays of the sun are striking at a shallower angle. They're not as direct. So basically the strength of the solar radiation is smaller during the northern hemisphere winter when the northern hemisphere is pointed away from the Earth. Obviously, the opposite things are true in the southern hemisphere. Another interesting point is that the tilt of the Earth and the rotation of the Earth around the sun determine the tropics. So the Tropic of Cancer and the Tropic of Capricorn define the points when the sun is directly overhead on the Earth's surface. So during the December solstice, that's basically during the northern hemisphere winter and the southern hemisphere summer, at that point in the year, the sun is directly overhead on the Tropic of Capricorn. During the northern hemisphere summer, during the summer solstice, the northern hemisphere summer solstice, the sun is directly overhead on the latitude that is the Tropic of Cancer. Halfway in between those 2 points, the sun is directly overhead on the equator. So those 2 lines of latitude are what determine the tropics, and obviously those are the warmest parts of the globe. Another factor that's important for determining weather and its variation over the Earth's surface is air pressure. Air pressure fundamentally is just the weight of the air pressing down on us. So air pressure varies with altitude. So if you go up in altitude, there's less air above you, and therefore the air pressure is less. You can think of it also as difference in air density. The air as you go higher in altitude is less dense. That's one of the reasons that people that are climbing very tall mountains like Mount Everest require oxygen, because the density of air and therefore oxygen is so low at those high elevations that it's difficult for us to breathe, to extract enough oxygen from the air when we breathe. So that's air pressure, and that varies with elevation. But air pressure also varies across the globe. So when you look at a weather map, we see both areas of high pressure, like this, and areas of low pressure. And those differences in air pressure drive differences in weather. Low pressure systems are also called depressions are often associated with high winds, unstable atmosphere, lifting, so lifting of those air masses. And so these are often associated with clouds, storms, precipitation, and other turbulent weather. High pressure systems are the opposite. They're associated with clear skies, dry weather, stable conditions. So sort of a bluebird sky day is typically associated with high pressure. It's not always pleasant. Sometimes high pressure can actually lead to some pretty extreme situations, and we'll talk about that in a minute. Those high pressure conditions with clear skies can also lead to, for instance, wider temperature swings over the course of a 24-hour period, because those clear skies allow temperatures to warm up more during the day because there's no clouds and solar radiation can heat up the Earth more. But then they also allow more cooling at night because there's no clouds to trap re-radiation from the Earth, and temperatures can get lower during the night. So we often see wider diurnal swings in temperature associated with high pressure. So changing pressure, measured with a barometer, for instance, often means that there's a change in weather coming or underway. And that's why barometric pressure is a standard measure in many weather stations, because those changes in pressure lead to changes in these conditions. And that's why those high and low pressure systems are indicated on weather maps as well. Another important factor in weather are cold fronts and warm fronts. So right here on this map, this line with a pointy edge is a cold front. So what that means is that cold air is pushing in this direction. So this is sort of a mass of warmer air here. This is a mass of cooler air here. Those fronts often lead to changes in weather. So that area where that cold air is encountering warmer air is often an area of changing weather, and you can often see precipitation, storms, and changes in wind direction associated with these moving fronts. A lot of that has to do with warm air lifting up above that mass of cold air, and as that happens, water will often precipitate out and cause storms and clouds and precipitation along that front as that warm air gets lifted up above that mass of cooler air. So those frontal boundaries are often also an important determination of weather. The jet streams are another important element of weather on Earth. We often say the jet stream when we're talking about weather, but in reality there are multiple jet streams. This figure shows sort of four main jet streams: the polar jets, which are near the Earth's poles, and the subtropical jets, which are located either further south or further north from the polar jets, are four of the major ones. These are basically atmospheric rivers of air. They move generally west to east. They're located 5 to 9 miles above the surface of the Earth. And they can move fast. Some of them may move over 110 miles an hour. You know, the jet streams can influence how airplanes move above the Earth. So if you have the jets, if you're moving with the jet stream, you can have a very quick trip across the Atlantic. The jet streams are formed by a couple of main factors. One is just the differential heating and cooling of the Earth set up the movement of the jet streams, but also the Coriolis effect, or Coriolis force also causes the setup and movement of the jet streams. And we'll talk about the Coriolis effect and associated cells in a minute. The jet streams are really important because they can guide the movement of high pressure and low pressure systems. They can guide the movement of hot and cold air, and changes in the jet stream can have pretty profound impacts on weather on Earth. Sometimes during the winter we hear about the polar vortex, and the polar vortex is just a system of unstable air over the poles that's really cold. And during a lot of the time, that polar vortex is contained at the poles by that polar jet stream, which just moves around that body of unstable air. But when that jet stream is disrupted, the polar vortex can move further south, or that polar jet stream can move further south and allow cold air to penetrate further south and cause those polar conditions to be experienced much further south. That shift in that jet stream can cause warm air to move further north than it normally might during the winter. Here's an example of a polar vortex intrusion event in 2021. And what you can see is, you know, the colors are temperatures. So these purple and blue colors are sub-zero Fahrenheit low temperatures. And basically you can almost envision the jet stream, which has moved, that polar jet stream, which has moved way far south, and it's allowing those polar temperatures in the negative degrees to penetrate way down into Texas and Oklahoma. Texas and Oklahoma are continental and can get pretty cold during the winter, but not this cold. So this movement of that polar jet stream further south and allowing that polar vortex to penetrate way south can result in some unusually cold temperatures during the winter. And this is a nice demonstration of that. Another example of the interaction of the jet streams in this with temperature, or actually with weather, is the development of heat domes. So heat domes happen when a mass of warm air builds up in the summer and is associated with high pressure. That high pressure system actually pushes down the air, and that compression makes the air even hotter. And as that happens, as that heat dome forms, it actually distorts the movement of the jet stream, and the jet stream can't move through that heat dome. It moves up and around it. And that movement of the jet stream up and around that heat dome actually then stabilizes that heat dome and keeps it from dissipating. So it holds and stabilizes that heat dome and can result in basically prolonged, extreme high temperatures for unusually long periods of time. So this diagram by the BBC was done in the early 2020s when we had a really extreme heat dome effect in the Pacific Northwest and British Columbia that caused record temperatures over a long period of time. This is another example of a heat dome effect that occurred in 2011 when in Texas we had prolonged high temperatures under high pressure, which also resulted in lack of precipitation over a prolonged period of time. This lasted sort of from late summer into fall and caused just some horrific drought conditions in Texas and Oklahoma during this period in 2011, and that was associated with a heat dome. The jet stream is also an explanation for a question that I've been asking myself here in spring and summer 2023 is, why has it been raining in the morning during this summer rather than our typical afternoon rain, thunderstorm, and rain shower events? And the explanation for that is a heat dome has developed in the southwestern United States and Texas. So that jet stream is moving up and over that heat dome in Texas and the southwestern United States. That's distorted basically the movement of the jet stream. That is holding that heat dome in place, and they're drying out and suffering in Texas again. But over here in Florida, basically what we're seeing is the jet stream is allowing low pressure systems to persist in the southeastern United States, and that's leading to that unstable and stormy conditions that's causing rain basically during all times of day, but also in the morning. That's a little bit unusual conditions for us, where we would typically be experiencing sea breeze, convective thunderstorms that I'll talk about in a little bit. The Coriolis force or Coriolis effect is another important large-scale thing that affects weather, and like I mentioned earlier, influences, for instance, the development and movement of the jet streams. The Coriolis effect, it's really complicated, but at its heart, it's caused by the rotation of the Earth and the drag of the atmosphere as the Earth rotates. What happens is that causes air in the northern hemisphere to be pushed to the east and the opposite in the southern hemisphere. And that drag ends up causing the formation of several cells in both the northern and southern hemisphere. So basically we get three major cells in each hemisphere: the polar cell, a mid-latitude cell, and a Hadley cell near the tropics. Those are sort of consistent circulation of air that's set up in those three zones. Those end up influencing the development of trade winds. Those trade winds are predominantly directional winds that are set up that move either easterly, so they're moving from the east towards the west, towards the equator. Those are the easterlies. And then further away from the equator, those have a predominant west to east movement, and those are called the westerlies. Those trade winds are called that because the movement of sailing ships were governed primarily by those trade winds and govern the movement of those ships. So those are really important directional sort of winds that are set up and determined by these Coriolis force cells.